to your visit. As I understand, there's a coach and a packed lunch, and I think we'll be back in about 2. So I thought it's just worthwhile passing this on. We talk about robots. I mean, I think we're probably preaching to the converted kinks, but one perhaps a mental model I'd like to give you is when you think about what is a robot. One useful way I think of thinking about a robot, it is a physical system, and a physical system which can be defined by degrees of at least these 3 things, which is, we talked about it, the degree of autonomy, the flavour of the artificial intelligence. A robot device without actually having some useful behaviour which implies some intelligence is probably mostly useless. So you're going to have different types of AI. And the AI that you have in a cruise missile, or the AI that you have in a smart assembly machine, is vastly different from the AI that you're going to require in a nurse robot, a robot that's going to take you to the laboratory. And the third element, perhaps, is the degree of shared attention and activity. So you can then have either different types of robot within that space. So you can have a teleoperation robot that's dealing with someone or not dealing with someone, and you could have a robot which is fully autonomous, doing whatever it is on its own and not being engaged with people. And that's really, I think, so you could have different types of robots, and of course you could have the same robot behaving in a different way and operating within that space. So at one stage making your sandwiches in the kitchen without you, autonomously, and then coming in and perhaps helping you to eat and being aware. I've seen that wonderful Charlie Chaplin film, Modern Times, where the eating, if you get the opportunity, do look it up. The eating machine is clearly completely unable to appreciate Chaplin's discomfort as it's piling in nuts and bolts, which it's confused for food into his mouth. So, and the other thing which I've left off here, but is, if you like, there's a fourth dimension, which is materials. And Jonathan has given us a fantastic insight into that, because smart materials means that we can defray some of the computational elements into the materials themselves. And this fantastic conflation of sensing, processing, actuation, and energy generation and storage in the materials then can affect whereabouts you are in this other dimension as well. And that's important. I often, I've run out of time, but I don't really see any difference between if you take the carapace of a bacteria and you're able to manipulate the internal metabolic processes to affect the behavior. I can't see why that's not a robot. Make a synthetic capsule for the body of the system. Why is it not a robot? And in fact, if you go back to 2,000 years and you look at Heron of Alexandria, made a robot, but it was not silicon, apart from the sand. It didn't have there were no computers, but what he did was this. Just a sort of quick, very briefly. Imagine you get a pile of very, very dry sand and you put a heavy weight on the top, and you bang a hole in the tube with the wet sand is, then the weight drops down. And if you attach a pulley and a rope over a pulley, and you take that over and you wrap it around an axle, then when the weight drops, the axle goes round. So now you've got something which would move forwards. And if you then, as you wrap that rope around the axle, if you put a loop in it, then as the rope unwinds, it turns the wheel until it reaches the slack. If it reaches the slack, then nothing happens. So now you've got a start and stop mechanism. If you put a wooden nail in the axle, you can wind the rope around and actually reverse the direction. Now what you've got is the weight drops, you can go forwards, it can go backwards, and it can start and stop. If you cut that axle in half and you have two cables going over the top, You've now got a system which will go forwards and backwards, left and right, start and stop, and that is programmable. There is no computer on board. And this, can you imagine 2,000 years ago, the effect of seeing a piece of stage come onto a piece of scenery coming onto the stage with no one pushing it. It must have been absolutely fantastic. My point is, it is a programmable system. It's a robot. It's made of wood and sand. We are in this fantastic. David spoke about the cusp. Just a reminder, in 1903, the Wright brothers took off. 66 years later, we put a man on the moon. The first Wright brothers flight was less than the wingspan of a Boeing 747. And it took 66 years with the current technology that they have. We've got more technology. I suspect that time will be a little bit, we'll accelerate that rate. We've now gone from this digital ether that we exist in, and now we're going into the kinesphere, if you like, where we have actuation. Bits don't interact with the world. Materials interact with the world, and that's where robotics comes in. So this second wave, I do agree with David, but I suspect that actually it will be shorter than we think. I've got to tell you about BRL very briefly, but we are probably the largest academic centre for multidisciplinary robotics. We have something like, well, depends who you talk to, at least 150. My secretary tells me it's 232 that we've got on the books. So there are a lot of people folk there. Our current research portfolio is around about 17 million pounds worth of live projects in the lab, total about 56. We have some 25 nationalities, and we have a pretty large laboratory, as you will see. I could also offer a little bit of an apology straight away, because you will hear some banging and bashing, because it sounds as if we've got a set of Godzilla next door. We're expanding. Some 32 million euros are being spent on the refurbishment of the building, which includes expanding the laboratory and also the construction of the University Enterprise Zone. And this gives us an opportunity of joining up R&D, innovation, and commercialization. So we do have a few people that have wandered through the laboratory, and so we think we're doing the right thing. VRL is really, the foundation of VRL is on 3 pillars. If you don't have academic excellence, if you don't strive for academic excellence in research, it's the sine qua non. Without it, you can do nothing else. But we also have considerable activity in education and training. So we have undergraduate streams, master's streams, PhD streams, and we're also a centre for doctoral training. I think at the moment we've got something like 54 PhDs running around, so that's it. And importantly, the third arm of BRL is this industrial engagement. And one of the areas that we're developing is our incubation, where we're very keen on ensuring that the culture of the laboratory is such that an individual who has an idea for a product or creation of a business, there is a conduit and there is support for that. So that's really quite, I'm quite proud of the fact that the students don't know any better. They just think this is normal, and it isn't actually normal in most institutions. The person particularly to talk to, I don't know if you get Jill's here, Jill Burnett, when we get to the lab, but particularly if you're interested in the industrial engagement side, then please make sure that you talk to Jill. There are a number of research themes that we're engaging with, and of course I'm very pleased that today 3 of those themes, swarming systems, teleoperation, and soft robotics were mentioned. But we do have a number of others too, and please go and have a look around and talk to the folks there. if you're interested in any of those themes. This is actually, it could be older than that, but it's very similar. You can see sort of construction of veins. Please stick your nose into the veins and talk to the individuals there. You've seen some of these things before, but just so you know how this is sort of confluence of, for example, some of the soft robotics things that we do in neuroscience. We're also involved with human-robot interaction. And see, this is a really important area. This is where, for example, the researcher here is asked for something, but the robot figures out that the human is attention is wanted, so he's not going to hand over the device. So this area of human-robot interaction underpins assisted living, it underpins flexible cooperative manufacturing. Really interesting theme. Jonathan mentioned the soft robotics, medical robotics too. This is part of the device. It's a little bit large at the moment, but if you wanted to, we wanted to develop the haptic device, the system which is actually inside the GI tract and is moving around in order to detect the annulus of tumours and report that information back to a clinician in such a way it's not simply a visual record of what's been sent, but also a physical haptic experience as well. Our system, this is panoramic, but we've built a bungalow in the middle of the lab with for our robot devices for testing for assisted living. We'll be able to talk to, for example, Molly there. This is Molly robot she will tell you that you should be or should not be taking your pills at a particular time. If you take your pills out of one of the drawers, then it's able to, the system is able to detect that and be able to pass that information to the robot. The robot is part of that technology. There's another robot lurking at the bottom there, which is for a mobile Skype machine, which is absolutely fabulous. I think, oh yeah, I've got it. All right, okay. So we do research, we do learning, we do partnerships and networks. Again, try and talk to lots of people. And of course, I mentioned again, we are a technology business incubator. It's an area that we're trying to build. I think what I'll do is I'll just simply, perhaps whizzing on, run out of time. But something I'm very keen on, or we're very keen on, is to try and join up an idea of the innovation pipeline. So we don't just do research and then it evaporates. We try to link it in with the opportunities for commercialization and exploitation. I think I'll stop there. Thank you.